a question, then do ask a questions, but please put it in me. So, well, I'll get started. My name is Salman Mishari. This course is going to be Six Sigma. It's a proficiency in general, but it is more targeted toward the green belt. So we are here for the green belt material, basically. And if you digest this material, you understand that you should be able to pass the green belt examination. It's like any other course, you know, you go and you attend a course in college or at the university. That's not enough just to attend. If you're going to the exam, then you're going to have to do some studying for it. So, but with this material and with the book that I will be giving you the title of, I think it should be enough to, if you understand the subject very well, it should be enough to be able to pass the green belt. Why is it not okay? Here is some background, a little bit of background about myself, and I am an engineering consultant with SM Engineering. I'm retired from Saudi Aramco with I don't know, 28 years, maybe 30, I don't know, I can't remember. I was also a part-time faculty at KFUPM. I'm a board member at the International Lean Six Sigma Institute, external consultant to some companies, and also local agent for the Welding Institute. I'm a reliability, RCA, and Six Sigma trainer. Here is some a little bit of my background, just been root cause analysis, vibration, etc. This is my education, and here is some my certification. I won't bug you too much with it, though. I will be moving to the course. Can everybody hear me? Can I just hear a couple of yeses from you? You can hear me fine, right?
From my side, yes.
Good.
Yes.
Yes, we can hear you.
So again, the purpose of this course, or these 3 nights, it is meant as a preparation, as I said, for a green belt exam. It is a good introduction for Six Sigma in general. So whether it's a green belt, yellow belt, black belt as well, it's a good introductory course for all these subjects. This course is for also those who will be taking the exam, maybe night 3 or something, tomorrow night or night 3. I will show you how to register for the exam. Then I will use my discount code to complete the payment, and then we will all agree on a date to take the exam. And once we set it up, we'll plan it. So this is our plan basically. Now this is a question or a thought actually, and I think I published it in Arabic and LinkedIn, is how to pass the green belt or black belt. To be honest, anybody can pass any exam, especially, you know, if it's there. If you study for it again and again and again, then as an exam, as a written exam, and anybody will eventually pass it. But if you don't understand the content, believe me, you have failed Six Sigma big time. Six Sigma in particular. If you don't understand the concept of it, if you don't understand the content, getting a certificate by itself, I'm telling you in advance, you are actually failing Six Sigma big time, because Lean Six Sigma is all about improving the performance. It's not about improving KPIs. And passing the exam is nothing but improving a KPI, basically. You want to have something look good in your CV. Maybe you want to show it, you know, to I don't know, to your employer or something. But that's only improving the KPI. If you pass it. If you really want to improve, then you need to understand the content. So that's the end. And unfortunately, many companies are like this. All they care about is to improve the KPI. And improving the KPI sometimes is not difficult. Just like passing the test is eventually not difficult. But if you really want to pass Six Sigma, if you really want to pass ideas for improvement, then you need to pass yourself, because you're only actually be fooling yourself. You're not fooling anybody else. So that's enough said. Usually around a class a class like this one, when I'm actually teaching in person, face to face, we go and we introduce ourselves all together. But for the sake of time, I think we will pass this time. I would like, however, to welcome our special guests, Professor Salman Shaheen and Professor Fayyaz Sayed from the Imam Abdul Rahman University College of Dentistry. Thank you for coming to our 3-night seminar. And also I would like to thank Mr. Khalid Abdul Wahid and his team from Saudi Petroleum Services Polytechnique, which is a primary player in preparing Saudi youth for their future in the energy sector. Thank you for attending. Thank you for coming, and I appreciate it. And you know, they're taking. I know that you are taking this thing very seriously. So this is why you are here. I'd like also to thank Mr. Mohammed Al-Mishawi. He is an ISO man, a quality trainer. So I attended some of his classes, and he is really good. So welcome again. The material that we will be covering, a lot of it is coming from this book. I suggest that everybody, it's an excellent book, and I suggest that everybody actually own a copy of this book. It's a good reference book, and all of you minimum bachelor degrees. So some of you are master degrees, some of you are PhD, some of you are, of course, professors. And a book like this, it's very easy. If you can pass web or dynamics or dentistry or whatever, I think somebody needs to mute his speaker. Like as always, I'd like to start with a question. How do I? Somebody is leaving his microphone on, and I think we need to really see how to mute. But can everybody please make sure that you are actually muting your microphone? So I'd like to start with a question. Being a teacher, I always like to give multiple choice of questions. I'm sure many of you have already seen these questions, but again, I would like to repeat it. Some of you haven't seen it before. I'd like to repeat it. It's a good introductory question to the whole thing of Six Sigma. So we say that once upon a time there was a hole in the middle of the street. And a poor man like myself, you know, he was driving and minding his own business, and he falls into this hole. And then people, you know, they take him into the ambulance, and they take him to the dentistry hospital this time, maybe because he broke his teeth, since we have some dentists here. So unfortunately, they couldn't repair his teeth, and he died, you know, basically. That's the story. Now, people get together and say we need to improve, because this is all about improvement. We have problems, we have defects, we have low performance, and we need to improve. So what do we do? So option one is to provide an ambulance near the hole. You know, you have a hole, put the ambulance near it. So when somebody falls into the hole, you take it straight to the hospital very quick. Others say, no, maybe that's not very fast. So no, maybe we should build a hospital near the hole. So when somebody falls, we can actually just take him to the hospital very quick. That's a, you know, I think that's a better solution. Option C is just fill up the hole and dig another one, make another one near an existing hospital. And option 4, which is D, is just to fill up the hole. So the question is, what is the best answer? Is it A, is it B, is it C, or is it D? And you know, what do you think? Anybody would like to give an answer? Well, the most obvious answer is that just fill up the hole, right? But unfortunately, even answer D is not the best answer, because filling up the hole by itself and without knowing why the problem existed in the first place, you haven't improved, okay? Because there will be in any businesses, in any situation, whether you're in a hospital, whether you're in a rig, whether you're in a factory, there are many holes there. And unless you actually go and take proactive measures to find where these holes, you will always find holes, and then you will be only firefighting instead of actually doing actual improvement. So that's it. So what are the holes in business? Holes in business in general basically are simply failing to meet customer requirement and expectation. Your customer, whoever this customer is, can be external customer, can be internal customer. If you're a maintenance service, then your internal customer is operations, okay? And these are customers, and failing to meet your customer expectation are actually the holes in your business. And they're very easy, actually. In every business, normally customers, you know, there are mainly three things, and some people, they add a fourth thing to it. They want things to be delivered on time. And unfortunately, many people are just keep waiting, your customer keep waiting for your service or your product to be delivered, and it doesn't get there in time. That's what frustrates your customer. Or it's the quality, the features. So he's expecting you to give them a product of this quality, and you're not giving it to them. Or it's getting more expensive than it's supposed to be. It's costlier. And the fourth thing is easier. So whether this is a cup of coffee, or whether it's a pump, or whether it's a dental denture maybe or something, all your customers, their requirement is actually these three things, or four things here. So if it's a cup of coffee, they want you to serve it to them on time. They want you to give it to the specified feature that they gave it to you. They wanted this, the temperature is this much. They wanted the level is this much, and so on and so forth. So these are basically, and all customers are like this. So this is the good thing about it. So the correct measure is basically gauged against requirement, customer requirement and expectation. But how do we measure our performance against requirement and expectation? How do we do it? Do we go and see how many times have we failed, and we take the percentage, for example, is the percentage of failure is sufficient? How many times? Is this enough? So that's the question. To answer this question, let's look at this performer. Let's say we have a performer A, which is 1 here, and we have a performer 2. And these are, let's say that both of them, this is their obligation or this is their requirement. They're supposed to be finishing something within 3 hours. Maybe in other businesses it's 3 days or 3 months, whatever, a specific time. And let's say this is the performance of the first one, and this is the performance of the second one. Which one would you think is better performer? Is it number 1 or is it number 2? Normally, especially for engineers, they say, well, let's look at the average. If we look at the average here, we look at number 1 average. So the average here is 2 hours. So that means that he is faster. He finished in 2 hours. Well, the average of this one is maybe what, 2.3 or 2.4 hours. So if we just take the average, we say, well, this one is better. And look at the average. On average, he is doing better than this one. And also, if that's added to a failure that this guy did, maybe one time he passed the 3 hours, that's a defect here, then we say, well, definitely, if you're just going to take these measurements, you're going to say, definitely, this one is a better performer than this one. While if we look at the data, we're just looking at the data, we know that this one has a higher risk than this one. Although the average here is better than this one, it is still, this guy is gauged better than this one. And if you understand this concept, then you have understand the first block of 6 sigma. Because 6 sigma is all about risk. How much risk? It's not just about the average performance. It's about 3 things actually. It's about the average performance. It's about the variation around that average. And everything is about your customer requirement, your commitment to the thing. So with these 3 things, you can actually measure how much risk you have in meeting your customer requirement. And again, this customer can be an external customer or it can be an internal customer. So how do we calculate the sigma level? What's the performance of this one? The performance of this one, this is the way we calculate it. It's very easy, but it is very, very powerful. The performance of this one is basically the distance between his average performance as gauged to the requirement. So you're required to finish within 3 hours, but your average is 2 hours. So how much risk there is? The way you calculate this is you calculate another factor or another parameter, which is the standard deviation, which is the level of scatteredness around the mean. So if you calculate your standard deviation and it happens to be 0.5, then you are actually called a 2 sigma performer. So your level is 2 sigma. Our target is 6 sigma, but with this level, it is 2 sigma. How did we calculate this number 2? Very easy. We just subtract 3 minus 2, which is 1, divided by how many standard deviation there is between 2 and 3. So the gap between our average and our requirement is 1, but each standard deviation is 0.5. So there are 2 0.5s basically. There's 1.5 here and there's another 1.5 here. So our performer or number 1 performer performance is 2 sigma. What do you think the performance of this one? If his average is 2.3, that's his average. He finishes normally within 2.3 hours, and the requirement is 3 hours. So what's the sigma level of this one? The sigma level of this one, same thing as we did here. We subtract 2.3 minus the average now. Sorry, we subtract 3 minus 2.3. So that's the distance here, divided by the standard deviation, which is 0.03. And this gives us a value of 23. So the difference between this guy is 2 sigma, and this guy is 23 sigma. And there is a big difference between 2 sigma and 23 sigma. What does this mean? What does this mean? So what is 2 sigma and 23 sigma and so on? What does it mean? What it means is this. If you are at, if your sigma level is 2.3, then you are 98% confident that you will meet your customer requirement. If it is less, 1.96, then you're only 95%. And it all depends actually in this, I'm sure many of you have seen is the normal distribution basically here. So here, what this means, this is your mean, and this is your standard deviation, 1 standard deviation. So between -1 standard deviation and 1 plus and 1 or +1 standard deviation, 68% of your performance actually lies there. So anything outside 1 sigma is going to be basically called a failure. Is this clear? Is this still, do I need to repeat this concept or not? Basically, let me say that again. All you need is you take data, your historical data, you calculate your average, you calculate, you get your customer requirement. What is your customer requirement? You calculate your standard deviation, you subtract this value minus this value, and you divide it by your standard deviation, you get a sigma level. From this sigma level, you can go to a table and you will be able to know what sort of risk do you have. Like if you are a 6 sigma, if you calculate yourself to be a 6 sigma, then your chance of making an error is so slim that only there is a chance of 3.4 in a million. So if you do something like a million times, the chance that you will actually fail to meet your specification is only 3.4. And this is why we care about 6 sigma. So this is basically the concept behind it. Now, let's say we measured our current performance and we said we want to improve. And this current performance, again, it can be time, it can be problems, features, errors, defects. You're fixing something or you're producing something and there are so many defects in it, so that's the way you calculate it. And let's say that this is our current performance. Let's say that this is our requirement, this is our mean, and this is our standard deviation. And we have calculated a sigma level of 2. And let's say we want to improve. What do we do? To improve, we only have 3 parameters. So to improve, we only work in these 3 parameters basically. How do we do, what do we do? Well, to improve this value, either you shift your spec up to increase the distance, so 3 minus 1 make it a 3.5, sorry, 3 minus 2 make it a 3.5 minus 2. How do I improve this spec? Just talk to your customer. Tell him, I cannot make this commitment. You're giving me 3 weeks and I cannot finish it in 3 weeks, okay? If you give me an extra half a week, I can be more confident of giving you what you need. The problem here from our culture, we always try to, unfortunately to say this, we just lie basically. Say, yeah, we'll do it. Yeah, we'll give it. As a customer, all we want sometimes is that our service provider or our product provider is just to be honest with us. If you can't do it in 3 weeks, tell me, I'll give you 4 weeks, but don't keep me waiting. This way you can improve your performance significantly, and we'll show this in numbers now, okay? Or, a better maybe option is to shift your mean down, the average. Basically, how do I shift my mean down, my average? Maybe sometimes just to start earlier. Just like somebody who's going to work late all the time. Maybe this time you need to wake up a little bit earlier. Okay, just get things, your things ready earlier. Get your suits earlier. Get your safety shoes. If you're wearing a safety shoes, your tools, get them ready earlier. Okay, so you just start things early. Or number 3 is to reduce this variation. And reducing the variation is also not very difficult. Just the standardization of things can actually reduce your variation significantly. Don't leave things to chance. Most of the time we leave things to chance. We just come and whenever we want to start a job, now it's time to look for our tools. That's going to, if you're lucky, you're going to find it right away. And if you're not lucky, if you're just leaving it to chance, maybe you'll not leave it. Procedures, you need the procedure, you need the data, you need all of this. So sometimes you're lucky, you need your boss to sign this paper. Sometimes you're lucky and he's there, sometimes you're not lucky and he's not there. So all of this create a variation. To be able to reduce this variation, all you need to do is set good standards, set good protocols, and make everybody follow this good protocols and communication protocols and so on, and just make things go much better and smoother. So these are the things. So let's say that we were able to change the spec from 3 to 3.5. Where am I here? Okay, let's say that the spec, instead of 3, I was able to change it. I spoke with my customer and I told them that I need to change it, and we changed it from 3 to 3.5. And let's say our mean, I was able to reduce my mean a little bit, and I was able, look, this is what I've been able to. Let's say that I have them 3, and then I was able to shift my mean to 3.5. I have my mean is 2, and I was able to shift it down to 1.5. And my standard deviation, let's say now currently is 0.5. And by putting good standards and so on, I was able to shift it to 0.3 just by improving these 3 parameters. How much improvement do you think I will be able to make? Well, here the calculation, as we calculated it before, we're going to subtract 3 minus 2 divided by 0.5, that's equal to 2. And if you look at the table, you look it up at the table, the chance of not meeting your customer specification, you have 5%. So there are 5% of the time you will not be able to meet your customer specifications. While with this performance, if you're able to actually change these numbers with this much, you are here 6.6 sigma. From 2 sigma to 6.6 sigma. And this is a chance of only 3 chances in a million that you will miss your customer specification. So that's basically, this is a quick conceptual introductory to 6 sigma and what it means. I hope that's making sense.
Sorry, Doctor, from
yes.
where we get number 4? We don't have 4 in this equation, right?
You're right, it's 3.5. You're right, correct. Thank you. I'll correct it, yes. Ahmed Ali, please make a note of this, that we need to change slide number 2.3. It is actually, you're right, it's 3.5 minus 1.5 divided by 0.3. And whatever this number is, but that's a lot of improvement. Please, if you have questions, just like our friend did, please, just ask it right away. Very good. So again, what is Six Sigma is all about? It's about making processes faster, cheaper, better, and easier. Faster is on-time delivery. Cheaper basically deals with the cost. Better, what do we mean by better? Better, we mean by providing what the customer basically wants, the feature that the customer wants. And of course, easier. The easier it is, your process is easier for those who actually are handling your process, the better yours. So if you get a question like this, that's the answer basically for it. This is another example of what Six Sigma is. This is just another illustration. Let's say you have 2 employees, and one is coming to work on average at 6:40, while the other one is coming on average at 6:50. 7 ل 10 و7 ل 3 basically. And let's say everybody needs to be coming at work exactly at 7. Now we have a meeting and the meeting will start and everybody is there and we're waiting for guy number 1 and guy number 2. Who is a better performer? Is it employee number 1 or is it employee number 2? If the mean arrival for the first one is 640 with a 5-minute standard deviation, and the mean of the other one is 650 with 1-minute standard deviation. The way we calculate it again is we count how many sigma there is between the average and the spec line. The spec line here is exactly at the top of the hour. So the difference here is what? 20 minutes. So how many 5 minutes there are in this 20 minutes? It's very easy. So it's 1, 2, 3, and 4. So this guy is a 4 sigma guy, the first one. Well, the other one is what's the sigma level of the other one? Can anybody say? Well, what are we going to do? This is the spec line. This is the average. We're going to subtract the spec line minus the average. So that's 10 minutes. And we're going to divide that by how many by the level of standard deviation. So how many standard deviations do I have from here to here? Anybody would like to answer? Basically, there is 10. So this guy, although on average, he comes earlier on average, but this guy is more reliable, basically. Because it's true that this guy comes later on average, but he comes sharp. When he comes at 650, he is at 650. You want somebody to come maybe at 659, okay? But reliable, coming at 659. And you don't want somebody to come at 630 on average, okay? But sometimes he is coming at 6 o'clock, sometimes he's coming at 7:30, sometimes he's coming 5 o'clock in the morning, and sometimes at 10 o'clock. If you take the average, yes, maybe will be something better. But we're not just talking about the average, we're talking here about basically the sigma level. So what is Six Sigma again? It is based on a statistical process control. The whole thing is, as you've seen, it is a statistical process control, and it uses sigma standard, or it uses the sigma, which is the standard deviation measurement. And the symbol for sigma is this thing, actually. This is the way it's written, that's sigma. So this is what we call it, Six Sigma. So, again, we've talked about this. One important concept in Six Sigma is the control limit. What are the control limits here? Let's say you have a performance like this one here. Would you be surprised if you see the performance of this one coming below 1? I wouldn't be surprised. Okay, because look at it. It's basically going there and there, sometimes here, sometimes there. So I wouldn't be surprised if it's actually at this level, if it comes below 1. I wouldn't be surprised either if it goes above 3. So at what level would I be surprised? And look at this one here. Would I be surprised if it goes above 3? Definitely. I say this process performance is never like this. There is something different about it. So I would be surprised if it goes above 3. And I will definitely be surprised if it goes below 1. So what determines when do I become surprised and when do I not become surprised? It's actually, these are called control limits. And the statisticians basically define this to be 3 standard deviation. The statistician says your performance is usually between -3 and +3 sigma. That's what it is. So now the second question, why do we say 6 sigma? If the performance expectation is between -3 sigma and +3 sigma, why is the question about 6 sigma? Who would like to answer this question? Who would like to give it a guess? No one.
maybe from -3 until 3, +3. So there will...
that is, most of the people actually uses this answer, and it's a logical answer, but it's not the answer. The answer is that these are your control limit. What does control limit mean? Means that any variation that actually happens within -3 sigma and +3 sigma, you shouldn't be too much worried about, because this is random variation. Any process has random vibration, random variation. There's, you know, somebody coming to work is not exactly by the second and by the millisecond and so on. There is always some variation. But the statisticians are telling you, you don't want to control any variation. It's only logical to actually control within -3 standard deviation or 3 sigma and +3 sigma. But if these are your control limit, you don't want your control limit to touch your spec limit. If your customer is requiring you to be at this level, you don't want to be running your process at -3 standard deviation and +3 standard deviation, because any problem that will happen will be directly seen by the customer. You will not have a chance to fix it, to look at it, to find the root cause analysis of it. We call them special cause. You will not be able to fix it. It will already have reached the customer. And that's it. So what they did, instead of 3 sigma, they said we want what they call is a double car garage. If you have a garage and then you want to park your car in that garage, you don't want to design your garage to be exactly the size of your car. You want to be wider than your car. So what is this? How much wider? The fathers of 6 sigma, they said we want it to be double. So if we can only control, if our limit of control is only 3 standard deviation, then we want to be our customer level requirement to be our spec level to be 6 sigma. It's just basically 2 times the control limit, and that's the choice that they chose. Now the question is, do we need to achieve 6 sigma? In some situations, yes. And we have medical doctors with us, and we have dentists with us. Medical surgeries, sometimes yes. You know, you would like to reduce the errors. Flight accidents, for example. You know, you're flying in an airplane, you would like, you know, to achieve it. I don't know, maybe in plant equipment, 6 sigma is probably too high of a target. But remember again, a performance, you know, the 6 sigma level is all about the performance and expectation. What is your performance and what your customer expect from you? As we said, maybe all you need to do is just you tell your customer that this is not what we can promise you. We, you know, this is our level, and this is how much we can give you. And many customers are very, very logical, you know, whether internal or external customers. They just want somebody to know what they're doing. They know their level, they know their capability, and then they promise what they can deliver. And it's not easy it's not difficult as we've shown, you know. Maybe sometimes all you need, and we did, you know, as a vibration engineer, and I know some of you have nothing to do with vibration, but sometimes when we have equipment that vibrate too much, what we do is, you know, we calculate the performance, and we change the setting. And instead of the equipment shutting down at 3 mils, we call it, we raise the limit and we put it at 4, and we know that the equipment is safe at that level. And all of a sudden, no alarms, no shutdowns, nothing, you know, the whole thing reduces. And that's what performance is. All the headache that we used to have before is no longer there without improving the equipment itself. All we did is just improving the customer expectation, or changing the customer expectation, basically. I said it's okay to be running at this level. So and I will show you other examples. Customers most of the time are logical, and practical, basically. You tell them that this is my performance. As long as you're sincere, as long as you know what your performance is, then you can actually avoid a lot of headache, basically. Again, what is Six Sigma? We're still in this concept. Six Sigma is data-driven problem solving. There's two parts in it, basically. It's data-driven problem solving. And what does data-driven mean? It means that in every phase, it's broken into phases, and in every phase, we're using data. We're not just using just judgment. This is the whole idea. This is why we do statistics. This is why we're going through statistics. The whole thing is coming from data. And this part from here to the left is all about data-driven. So data clarity is very important. You use graphical techniques to represent this data. Data quality also is emphasized, because garbage in is garbage out. You need, if you're going to make your decision based on data, you need to base it on good data. And we use a lot of statistical techniques. So this is the data-driven part of the story. It's a problem solving. What's the problem solving here? We use a structure approach into solving the problem. And what we normally use is the DMAIC. It's pronounced DMAIC, like making something, so it's DMAIC. D-M-A-I-C. It's a problem focused. We look at a specific problem that we are having with our customer. Let's say we are a training department. We're training people to work for facilities. Then we want to see the problems. We want to focus at the problems that our customer has with us. So that is very important. And it's a rigorous approach. So what does rigorous approach? It means that we have to complete each step before going to the next step. And it's also a simple approach. It's not a very difficult approach as an approach. Yeah, some of the details, mathematics and so on, might at the beginning be a little bit overwhelming. But you know, and just like anything else, if you just look at it, you break it down into pieces, you will find out. You need a learning curve in it. But after all, after sometimes you will see that it's not difficult, the math involved or the statistics involved. And it's a generic approach, meaning that it applies to various industries. The same approach. It applies to dentistry, it applies to manufacturing, it applies to training, it applies, you know, so it's just the same concept. Basically, you're taking data, you're analyzing these data, and based on data, you're trying to come up with improvement to your problems. So it's a logical flow to the problem. Basically, the DMAIC process, as we said, it's a define. You define the problem, you measure the problem, and if you can't measure it, you cannot improve it. And once you measure the problem, you take the data and you analyze the problem. Then, after understanding the problem, you go and you put improvement to the problem. But the most important one is probably the control. And I'm sure in all disciplines, we've seen many times where we actually took a problem, we investigated it, and we put solution for it, and we improved it, and we've seen that this solution worked. But if we come back a year later, we see that things just went back to the normal practice. Why? Because it is missing the control part of things. You can't just improve. You come to your environment, and you do many things and you fix things. And then a year later, just things go back to where they were. So the control part is very important. So basically in the DMAIC, the define, what you do here, you develop a clear project charter, you put a charter on a real significant problem, and this has to be related to the customers. When in Aramco, for example, when I was there, each problem has to have a potential saving of $250,000 to be able to take it as a significant. Of course, from a place to place, it's another thing. Safety is also a factor, but that's one of the things. And the good thing here is that if any organizations like SPSP or the dentistry department or all the other places or any organizations, basically, they come and they take a few problems. Let's say we take 10 problems and we assign 10 people to work in these problems. They don't have to all succeed to claim that you succeeded. Even if you succeed with the 3 or 4 projects, and you make significant improvement, and that's what we did actually. We were able to go all the way to the president to share with him our success. Basically, we took problems, and some problems were really significant, and we were able to improve them. And maybe it's time to emphasize this point here. Six Sigma is an improvement initiative. It's not a training initiative. We have to isolate these two concepts. Improvement, that means we are at the organizations, we're having a problem with our customers, we're not meeting their requirements, we're not meeting their delivery time requirement. Our products that we give to them, there are a lot of defects. If they are trainees, for example, they go to work and there are deficient, some of the things they haven't learned or so on. If it's whatever mechanical seal, then the seal is broken, or whatever, it's a cup of tea, then it's not hot enough, whatever it is, okay? And we take the major problems that our customers have, and we charter people, we assign people to work in these projects. And we follow on these projects. We don't leave it, it's a top-down, basically, approach. Is not a bottom-up. The management has to take lead in it. So when the management takes lead in it, and this, periodically, every maybe 2 months or something, people get together and with the management, and everybody will come and present his project, where he is in his project. And the whole thing is targeting improvement. And the way we keep, the Six Sigma infrastructure is like this. You have people trained as yellow belt. We have people trained more focused or more specialized as a green belt. We have black belt. The black belt will be fewer in number than the green belt, and so on. And maybe we have 1 or 2 master black belts, or we could rely even in universities or something like this, or external consultant. But the idea here is that we have it's an improvement initiative, and it works if it's taken as an improvement initiative. So what I suggest for you, everybody of you, if you want to take this any further, I know some of you may not be at the authority level, but if you can find a chance to go to your management and make a presentation about what Six Sigma can do for you, and maybe define a few problems and say these are the problems that we have, and this is the approach that we're going to take, and take their support, then you probably could go forward with your Six Sigma more than if you just take it as an individual initiative. But let's go back to the demake process. So it's defined. So you develop basically a clear charter of a real significant problem. You go to measure. Measure to establish. After you define your problem, you want to establish baseline performance. What is my performance now, currently? And then that's using KPIs and so on. Then you analyze, you find the root causes, and once you find the root causes, you develop solutions for it. And then you go to the control phase, as we said. Another concept here that we hear Six Sigma, and we hear Lean. And these two basically are they complement each other. And the lean process, what does lean mean? Lean means, as we say in Arabic, rashiq. Not like myself, I'm not rashiq at all, so I'm not lean. But lean means that all the fat is out. So if you have a process, okay, then you're taking all the fat out of your process and making it lean. So a lean process delivers products that the customer wants. What is it that the customer wants? At the price that the customer is willing to pay for. And what do customer wants? Customer wants things immediately, basically fast. They want them flexible. They want them the way they like them. And customers are not willing to pay for you making too many products. Sometimes you're just overproducing. They don't want to pay for this. So this is an area of cutting costs. They don't want to pay for throwing faulty products. You're making faulty products and you throw them and you're throwing them away. Or they don't want you also to be wasting energy during the provision of their product. So all of this waste, they want you to remove it because they want to pay only for what they are willing to pay for. Now, where do Six Sigma projects come from? They come either from external voice of customer, VOC means voice of customers, or internal voice of customers. They come from strategic goals, or they could be coming from local initiatives. They come from major change programs. We have a problem, big problem, and then we need to do a major program, or maybe as small as an employee suggestion. So this is from top to up, is like internal, from up to down is like external. And other top down and other bottom up, basically. So this is an introduction about what Six Sigma is. Now we're going to go through the DMAIC